Good afternoon, everybody. Welcome to another exciting afternoon of Organic Chemistry, Chem 170, with your host, me, Dr. White. And today will be a quick day because we're essentially finished up with things. Uh, but there's some things I'd like to go over. First of all, let me remind you, after class today, within about 10-15 minutes, I'll be sending out an email with the password for test number 4. Please upload your answers for test number 4 by sometime tomorrow. I think I have it set for either 10 or noon, but try and get it in before the afternoon so I can start grading it. Uh, as I'll say in the email, I should by at the latest Sunday, 1 p.m., probably a lot earlier, have your test scores in D2L. Also, over the weekend and the holiday, D2L was acting funny. It wouldn't let me upload grades. I was able to do it yesterday. So you should see most of your most recent lab scores are now in D2L. Don't forget the deadline, I believe, is Thursday or Friday for the extra credit project. If you want today before the deadline, email me your project. I'll take a look at it and tell you if you got to change something. And that way you can get 10, yes, 10. Yep, I still have 10 points, not 10 fingers, but 10 points. By the way, my hands are still chiral. And uh, let's see. Don't forget to hand in the lab that's due today, and all the other labs you should be up to date, or contact me and I'll help you out in case you no longer can upload them to D2L. With that, since I sort of sped through it, a couple things I'm going to do today. One, I'm going to go through the protein and amino acid chapter again. I think it'll help you because I don't really have a problem set because there are not that many problems I could put in a problem set. And Dr. White is a lazy organic chemist. Sometimes, like a lot of times. All right, that's one thing. Next thing, I think is would be helpful to all of you if I go through some more important information for test number 4. And then I've got a surprise for you. But that surprise I'm going to cut out of the video because I have to. If I leave it in, I'll get arrested. No, I won't, but I'll cut it out. And we'll also go through today's lab. Now, one quick question for you out there. Did I already talk about drain and grease cleaner? I think I did, didn't I? Did I already talk about Barkeeper's Friend? I thought I did, but I just wanted to check because I didn't want to leave you out of the good stuff, how to do things. All right, let's get going. Let me first close some stuff. All right, everybody see chapter 17 on your screen? Thank you. Zoom always tricks me when I don't ask. All right, let's go through this again. First of all, this chapter deals with amino acids, peptides, and proteins. As you all know, amino acids, peptides, and proteins help keep us alive and are very important in our daily life. Well, what's an amino acid? Amino acid is a compound that has both an amino group, an amine, and a carboxylic acid group in the same molecule. Now, here's one way to write it. A better way, which one of these days I'll change this to the better way, but it's not today. Is like this. All I've done is rotated the bonds around that carbon, which you can. Now, the amino group in an amino acid is always on the alpha carbon. The alpha carbon is the carbon bonded to the carbonyl carbon of the carboxylic acid. I hope you didn't forget that the carbonyl group is carbon double bond to oxygen. I don't know of anything more important to me personally in all of organic chemistry. So amino acids again, carboxylic acid, and on the alpha carbon, you have an amino group. Sometimes it's a little more complex than an H2, but a lot of the times it isn't. Now, when we talk about amino acids, which is really short for amino carboxylic acids, but organic chemists and really protein chemists are lazy like, and they just cut out the word carboxylic. The alpha carbon when R is not hydrogen, then this carbon has 4 different groups or a combination of atoms and groups, hydrogen, amino group, carboxylic acid, and R, as long as it's not hydrogen, and therefore it's chiral or chiral carbon. And that means whenever you have a chiral carbon in a molecule, most of the time, there are a few exceptions, but we don't cover them in this class, that means amino acids are chiral, except for glycine, which I'll never ask what is glycine. That's when R is a hydrogen. Then it's not chiral. But other than that, most amino acids are chiral. That's something you should know. Now, an amino group is a base, a carboxylic acid is an acid, and at pH 7, this base will attract this acid. It goes over here. This is now has a positive charge. It's lost a proton. It's got a negative charge. And notice there are 2 charges in the same molecule on different atoms, nitrogen and oxygen. And we call that a Zwitter ion. That will not be on the test. Or, well, this stuff I'm talking about right now will not be on test 4, but some of it will be on the final. This will not. But still, for your other classes important, you might want to know. Like I said, a Zwitter ion, and by the way, Zwitter ion comes from the German word zwei. Zwei is 2. And Dr. White speaks German. I worked in Germany at times, and my German's awful rusty now because I haven't used it in decades. But I still, when I'm speaking a German word, pronounce W's like a V, which is how they pronounce it in Germany. I think I'm spelling it right. This is equal to 2 in German, zwei. Oh, wait, time to show off. Let's see if I can still remember how to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I do. And let's see. Ich heiße Herr Dr. Weiss, which I just said my name is Dr. White. And in Germany, it was always interesting. It wasn't Dr. White, it was Herr Dr. White, which means Mr. Dr. White. And that's German language for you. For those who are wondering, I worked in, when I was in Germany most of the time, I was in a town called Emmerich, and that's right near the Dutch-German border. But I stayed in a really tiny little village called Hoch-Elten that I've stayed in a place that had 15 suites only and had a 5-star or 4-star restaurant. That's, if you know your restaurants, is quite fancy. That's because I was a senior manager. Dr. White's showing off now. But back to important stuff. Now, you learn for test number 3, if you take a carboxylic acid plus an amine, you'll get an amide. And remember, R prime and R double prime, either one or both can be hydrogen. In this case, we'll call this R prime, and one of these I'll call R double prime. And here you have your carboxylic acid, your amine, and notice right here, I'm forming my amide bond. And that's how you link amino acids together. Now, if you notice, at this end, I still have another amino group. At this end, I still have another carboxylic acid group, so I can attach more amino acids. Now, here I have the same two reacting, but they can be different. Now, switches off for this slide. The previous slide you should know, but this one, a peptide is a covalent bond between the carboxylic acid of one amino acid and the amino group of another. And Dr. White is not a protein chemist, so I just call it, like right up here, an amide, which it really is. But if you're a protein chemist, you call this a peptide bond. One of these days when I have a lot of free time in my hand, I'll have to look how did the name peptide come about? But not today. So peptide bond, when you hear about this in other classes, is really, now you know organic chemistry, an amide bond between two amino acids. Now, protein chemists have somehow decided that a peptide is a molecule containing two or more amino acids, in which the amino acids are joined together with an amide bond. They'd say, no, it's a peptide bond. It's really an amide bond. But Dr. White's a synthetic organic chemist. Now, when you have a protein, that's when you have a peptide where you have a long polymer of at least 50 amino acids joined together by, they say, peptide bond. Dr. White calls it an amide bond because it is. So if you think about it, if you have 50 or more, let me redo this. If this is N, well, it's an awful N, I apologize. Let's try better. That's better. If N is greater than or equal to 50, and these can be the same or different amino acids, you have a protein. So it's time for Dr. White to ruin your lunch, breakfast, lunch, or dinner. The next time you eat something with protein in it, like if you're not a vegan and you eat a good juicy steak or nice hot dog or hamburger, or better yet, salami. Dr. White loves salami or corned beef or pastrami. Get off it. All right, but anyways, or if you're vegan and you have some soybeans, which are chock full of protein, Dr. White also loves soybeans, you're consuming a polymer of proteins where N is much greater than 50. And remember when we talked about polymers, it was like box cars hooked on together, one after the other, like in a long freight train. Well, that's all that is. Now, to really scare you, I want everybody touch your skin somewhere. Go ahead. Hopefully it won't hurt. Do you feel all those amide bonds? Your skin is a monster polymer of protein. And if you had x-ray vision, nope, I didn't wear my special x-ray vision glasses. Did you ever see those in the back of comic books when you were a kid? 10 cents, and they have these little circular lines and two holes. My best friends sent it in. I said, no, that's going to be a ripoff. We sent in his nickel or dime, whatever it was, and his parents let him do it. He got it. He came over to my place. And, I got it. And he put it on. I say, well, can you see the bones in my hand? No. I told you so. That was Dickie Gale. I haven't seen him in decades. I hope he's still alive. We had a lot of fun together. But now when I kidded him about it, his X-ray vision glasses. But think about it seriously. This is protein. By the way, what's left here is protein too. And this too. Your hair is protein. Your muscles are protein. All those good things in your body, a lot of it. I bet you never thought it's all due to organic chemistry and also Mother Nature. And that's why, if you remember the first day of class, I said I really laugh inside when I hear someone say I hate organic chemistry, because what I really know is they meant I hate whoever taught me organic chemistry, because it's fun. See, you learned that this semester, I hope. All right, now, this is important. Again, this isn't for test number 4, but you should know it for the uh, final. Hold on, I forgot to shut off spell check. And I don't think you want to see all those squiggly lines. We're at ECC. The first thing I do when I get into a room is shut off the spell check. All right, now you should know what happens when you consume a protein. And what happens is your stomach and intestines, I think once somebody told me it was your small intestine, but don't quote me on that, because last time I had a biology was freshman year of high school. But your stomach and one of your intestines breaks down the proteins to amino acids by acid hydrolysis of an amide. Remember, that other people call the bond between amino acids peptide bond, but let me rewrite this. And when you eat a protein, really what you're doing is the following. Hydrolysis, and it's acid hydrolysis, and I'll use HCl. Why? Because that's the acid in your stomach. And every time I say that, I think of the miracle that's going on in my body and yours, that I have cells that actually synthesize, that's the fancy word for make, hydrochloric acid. And as you learn for test number 3, you get back the carboxylic acid you would have used to make that amide, plus the amine salt. You would have used the mean salt of the amine you would have used to make that. Because remember, in the presence of acid, amines are bases and they accept the proton. And this is another way of showing it. Here I have one amino acid, here I have a second. You break this bond, that's your protein, also called the peptide bond or amide. Now let me rewrite this. And here you have this amide bond, and you break it to this carboxylic acid and this amine salt. Now, it just so happens this amine, which is not involved in this reaction, will react with the acid. It's an acid-base reaction to form the amine salt. Now, look what Mother Nature has done in your stomach. When you break down food, you form amino acids, but they're really amine salts, so they're ionic. And as you learned about soap, like dissolves like, if my stomach is mainly water and so is my blood, how can Mother Nature help transport amino acids throughout my body? Make it ionic. And she did. All right. You should know from this chapter when you eat something with a protein. Oh, I think I even spelled protein right. I always spell it wrong. Everybody see that in the whiteboard now? Thank you. You should know how to describe it with words and a general reaction. What's the functional group in a protein? You should know that's an amide. Therefore, this is acid, hydrolysis. Oops, that R is off in left field. Of an amide. And the general reaction that you learned for test number 3 is you get back to carboxylic acid you would have used to make this amide, plus the amine salt of the amine. Now, I put my charges in. If you don't, that's okay. I had a student who was charge averse a number of years ago and convinced me it's okay. And life's too short to get bent out of shape for charges. All right. Key things you should remember. What's the structure of an amino acid? Again, this is not for test number 4, it's for the final. I forgot how many points when I write a final I put for, oh, I got to do that next week. Yeah. But anyways, it'll be about 4 to 8 points on amino acids and proteins. But you should know, one, the structure of an amino acid. You should know how to tell if there's a chiral carbon. Which one is it? The alpha carbon. And next, you should know how do two amino acids come together to form a amide linkage by reacting amine and a carboxylic acid to form the amide linkage. Other people call it a peptide, but I'll never ask. And then you should also know how your body breaks down proteins when you eat it, which is how to describe what a general reaction and with words what happens when you eat something with protein and swallow it. Did I tell you? I think I did, but when I was about 2, actually down here too, my mother said, chew your food or you'll choke. Chew your food before you swallow or you'll choke. And guess what? She was telling me the truth. And I survived, luckily. All right, any questions on amino acids or proteins or peptides? Again, I don't have a problem set. Oh, here I can give you a problem. draw the structure, give the name of a product or products that you would make when you treat a protein with HCl and water. Ooh, I just gave away a good final exam problem. Shucks. All right, anybody need more time? Okay, let's do it. Well, one thing you could put down here is amino acid. And if you put amino acids, that's fine. And you could have also drawn it like this. Now, if you didn't put this as a salt, I wouldn't take points off. Notice the alpha carbon has the amine salt because you're in the presence of acid. And that's how you do it. All right. What I think I want to do next is let me go through the lab, then I'll have your surprise, and we may take a little break, and then we'll come back for important things I think I should cover again for test number 4 that will help you out. All right, everybody see the carbohydrates lab on the screen. Thank you. All right, today's lab deals with, it says carbohydrates, but it really deals with starches. Now, as you know, a carbohydrate is any molecule that has polyhydroxyl ketone or polyhydroxyaldehyde, or a molecule which upon hydrolysis, adding water or acid and water, will break down to polyhydroxyl ketone or polyhydroxyaldehyde. Now, in this lab, let's talk about starches. Now, starches, as you know, are many glucose molecules bonded together in a polymer. And it turns out you don't have a straight chain like we have, like with a carboxylic acid with a long R group. Because of the structure of the glucose molecules linked together, what you do see in starches is a helical structure. And all along here are your different glucose molecules in a cyclic form, which I showed you looks like this if you use Dr. White's handy dandy quick way of drawing the cyclic form. Remember, this is connected to the hydroxyl group of another glucose molecule. But what that really looks like, now let's do a little internet search. I've never done this before. By the way, David Korn is a here they have it sort of showing linear, but you notice each ring has hydroxyl groups here, like here, here, and here. Same thing repeating. And starch, it's about 300 to 600 of these hooked together. A lot. It's a polymer. And what it means is starch has all along this arcs hydroxyl groups from here. Well, this one's actually taken from here, here, and here. And those hydroxyl groups can interact in a certain way when it's in a long polymer that's spherical, helical, trying to get the right word because I don't use that word that often. And, ooh, I'm not on my whiteboard either. Now, what we've done a lot this semester, and if we were in the lab, you would have seen it firsthand, and that's sort of sadness for me that you didn't have the experience to actually go in the lab and have some fun. But hey, I didn't pick, I don't think anybody expected what happened in our life with the virus, but at least we're moving on. You're learning organic chemistry. That's a good thing. Now, a lot of the early chemistry in the late 1800s, 1900s, before they had what we now have, modern electronic spectroscopy equipment to help identify compounds, they went by visual methods. If I add this to this, does it change color? Oh, that tells me it's this or that. And one of the things scientists or chemists were trying to find out is that stuff have starch in it or not? Well, how do you tell if you don't have modern equipment? Well, you have something that will change color when it's induced or introduced or come in contact with a starch. And it turns out there's something very interesting that will do that, and that's iodine. Now I'm on my whiteboard. Now, if you have iodine, it's a red brown color. And if you introduce it to starch, when the iodine is inside the helix, this changes color to a very dark blue. So dark, you might think it at first glance to be black. That's how dark it is. Now, if I have this, a single glucose molecule, either the open form or cyclic form of this glucose or fructose, this will not interact with iodine. In other words, it won't change the color. So if you have a starch, iodine will change color to dark blue. This is a carbohydrate, but it's not a starch. This is a monosaccharide. And it's a carbohydrate, but it's not a starch. And therefore, I can tell starch by iodine. There's one problem with iodine. Iodine is a solid and is non-ionic, so it's not soluble in water, so it's pretty hard to use. Well, chemists found the following. If you take iodine and react it with either sodium or potassium iodide, you'll get this reaction. And now this is ionic, and this is now soluble in water, or also in water ethanol solution. And I'll explain why in a second people did that. And that's easier to use because now you can take a liquid, put a few drops on something. If it changes dark blue, you have a starch. If it doesn't change, you don't have a starch. You can still have carbohydrates, but you don't have a starch. And so chemists use this. Now, when this is in solution like this with ethanol, it's kind of interesting name, tincture of iodine. And it's been around for eons. Now, if you go to Walgreens or other places, at ECC, we make up our own solutions. When I've done this lab at COD, at that time, the lab manager was lazy, so she went to Walgreens and bought it, which was way more expensive than if she'd made it herself. You can buy little bottles of tincture of iodine, and it's made up of iodine with potassium or sodium iodide to make Ki3 or NaI3 ionic, and it's in water and ethanol. Now, if you take the bottle and unscrew it, you'll see in the cap on the bottom is a long, about this long, plastic rod. And before they had the stuff now we treat cuts for, when I was a little kid, if you scraped your hand or your knee or something, your mother said, all right, come inside. And then it usually used to be in the medicine chest in the bathroom. Take out the bottle of tincture iodide, take the little rod, and you can put a few drops and spread it over your cut, and that will stop it from getting infected. There was one problem. The ethanol in there stung like heck. Oh, it hurt, especially if you had a decent cut. Oh, it hurt. I can still remember. Well, for those who are old enough, a number of years later, a company found a way of making another type of antibacterial or microbial solution for cuts. It was called Bactine. And the whole thing they sold it by to mothers was it doesn't sting when you put it on, which was a big selling point, and they did quite well. Now you can buy all your different chemicals. What's the uh, some in a tube? There's 3 different antimicrobial things. I have one. I can't think of the name. But anyways, so today's lab, if we were in ECC, I'd have spread out a whole bunch of very dangerous chemicals for you to find out, are they starches or not? Let's look. And those dangerous chemicals are potato, bread. I'll skip the cheese. I'm going to come back to that. Flour, cereal. I think we used to use Cheerios. Sugar, honey, and cornstarch. And if you were there, you'd take a little of each, put it on a glass plate. I can't think of the name of it right now. A watch glass, now I can, and put a couple of drops of the tincture of iodide. Notice here, tincture of iodide, Ki plus iodine will turn will turn blue or dark blue. Actually, a lot of students thought it was black. That's how dark a blue it comes, from the reddish brown, and when it is in contact with any starch. As I said, this is due to the helix form of the starch molecules. This is not for carbohydrates, all of them. This is for special carbohydrate starches. Now, a couple of funny things. See where it says bread? Some of these things ECC wouldn't buy. And I was told, well, if you're going to do this lab of yours, you got to bring it in yourself. So instead of bringing in bread that would at the end of that wouldn't be good by next semester, I brought in something that lasts forever, and that's matzah. And Dr. Daly, who does all the labels, unfortunately, you haven't seen his handiwork. He's been a godsend to us, and the lab manager, he's also a part-time faculty. labeled everything. And on that label, the first year or so we did that lab, he just put matzah. And students would come to me and say, Dr. White, where's the bread? I laughed and I said, obviously you've never been to a Passover Seder, because matzah is just water and flour mixed together like bread, but a little different. And so after enough problems, I asked Dr. Daly, can you change the label, put bread? And he said, all right. And he put bread, and underneath in brackets, he had matzah. And then but it was so funny. Where's the bread? That's what happens when you're being brought up in a Jewish family in a Jewish suburb where everybody knows that. And you come into somewhere like Elgin where nobody knows that. But anyways, let's also talk about the cheese. I would have to bring in cheese. And the first time I did it, we'd freeze it so it lasts. We're running low, and Dr. Daly, his name is Pat Daly, said, you better bring in some cheese. And those things I'd have to buy. And you guys were worth it, so I did. And so Dr. White got cheap, and my local supermarket, Valley, had a sale on, the individual sliced cheese, but it was their house brand, not Kraft. And I don't know, Kraft might do the same. So I brought it in. It's cheese. And students tested it and said, it's turning it dark blue. And I said, I can't, it's cheese. So I looked at the package, I happened to have it, and it said starch filler. So next semester, I bought some very expensive white cheese. I read the label, no starch filler. And if you look at the lab, you'll see the yellow cheese turns the tincture of iodide dark blue, while the white cheese, it doesn't. I put down brown. You could put reddish brown. I guess I was lazy. And then you have to answer the questions. Now, hold on one second. Let me see if I can find something. Okay, let's see how good it is. Everybody see YouTube on your screen? Thank you.
In this video, I will demonstrate.
Oh, look, it's starch. Like cornstarch. See how in the eyedropper was reddish brown? Now watch when they put it in water. See how it's a reddish brown or brown? And with starch solution, see how it turns that dark blue? It's beautiful to see. And if you look at it, you might even think that's black. So now you've seen what you would experience in the lab on screen. I feel better. I don't know what's in that one, but it's obviously not soluble. But anyways, if you want to see more, go to YouTube, put in starch and tincture of iodine. Let's see, they have any, oh, wait. Someone stole my lab. You notice good chemists have beards?
Yellow brown in color. Note the change in the color of iodine as it is put on the rice and potato. Both turn the iodine blue-black. Put some iodine on the sugar
blue.
cubes. The color does not change. Salt too does not change its color. This proves that sugar and salt do not contain starch, while the starch in rice and potato reacts with iodine to form a blue-black compound. Now, the reaction is because the blue-black color is basically the formation of polyiodide chains from the reaction of starch and iodine.
Now I feel better. You've experienced,
Testing for starches in food.
hold on. I always
We need a
think,
balanced diet to give us the energy we need to work and play.
I always forget to shut off YouTube because it'll go on to a new video. But anyways, that's today's lab. You have some questions to answer, and that's that. How are we doing on time? All right, let's take a, how are we doing? Oh, let's go a minute or two more. Any questions about the lab? Any questions about the meaning of life? I'm still trying to work that one out. Well, in that case, let's take a break. We'll take a little longer break. Come back at 1:55 and we'll continue. I want to go through a couple things, but first, well, go through a couple things and also have a very special surprise for you. I mean, it's special. I'll see you in about 1:55. That's a little more than 5, but I'll see you then. Uh-oh, I'm running late. Sorry about that. Let's get back to work. Sorry about being late. I went and checked my mail, and after I get my mail, I always wash my hands. And also I stopped by because it was bothering me. I think you're all familiar with the triple antibiotic ointment. And I've never looked up the stuff, neomycin, sulfate, and whatever these others are. It works, thank goodness. Hopefully you have that in your medicine chest too. All right, I was just thinking of something I haven't talked about. Next, not a week from today, which next week is our last week of class together, because the final is the week after that, and I'll talk more about it next week. But in fact, by Monday, I'll probably post the final breakdown. Best way to study for the final, use your hourly exams as practice problems. Will I put the same problems? No. Will I put similar? Of course. Look at my practice problems. Aren't those similar to what's on the test? So anyways, uh, a week from today, after class, and it's totally optional, but I highly recommend you stop by because I'm going to cut it out of video. I will go through important tips how to interview. All of you will interview at some time in your life, either to get into a school like nursing school or to get a job. Trust me, I've interviewed, plus I hired. And a couple of years ago, when I started teaching this to students, I was amazed at the results, very positive results they got, because most people have no clue how to interview. And therefore, they come off looking pretty bad. And my students who walked into an interview, whether it was for nursing school or for a job, just wowed the people on the other side who were interviewing them, because they knew how to interview now and how to do a good interview. And my tips work. So I'll do that next Wednesday after class, totally optional, but I will cut it off of the video. If you can't make it to class, come to my office hour next week on Wednesday and I'll do it then. All right, what I'd like to do now first is go through a couple important things for test number 4 that will help you. And then I have a special surprise. All right, can everybody see my whiteboard? Thank you. Whenever I don't ask, Zoom tells me you should and you can't. I got to redo something because that's a bug in Zoom. First thing you should know, and also leaving my class, you should know, how does soap work? And the first thing you should know is, what's the structure in general of any soap? And soap has a nonpolar tail and a polar head. And if I were doing this on a whiteboard at ECC, you'd see me write as large as I can. The most important thing, how soap works, is light dissolves light. And that's things that are polar are soluble in polar things. Things that are nonpolar are soluble in nonpolar things. And if you try to mix the two together, polar and nonpolar, they're not soluble. And you learned that in the lab. And you should know, for how soap works, water is polar and grease and dirt are nonpolar. So if you just take water, you're not going to get dirt fully off your hand because guess what? It's nonpolar. Well, when you use soap, what happens? And water. Let's look at a very tiny particle of dirt. It's nonpolar. When you use the soap and water, the nonpolar tail of soap is attracted to the dirt because of light dissolves light. And it does this. Well, there are a lot of molecules of soap you use. And if you remember the picture I had in my slides, this surrounds this dirt molecule 180 degrees all around. And this is called a micelle. You should know what a micelle is. Now, water looks at a micelle and only sees the polar heads of the cell surrounding the dirt particle. And water says to dirt, oh, I'm polar, micelle, you're polar, let's go down the drain together. And they do. And that's how you get your hands clean, your dishes clean. Use a slightly different structure of soap, but it's still non-polar tail, polar head. And that's how you clean your laundry. Use a soap or detergent, which also has non-polar tail, polar head. Now, the other things you should know leaving my class and also for test number 4, how do you describe with words and a general reaction when you eat something with fat or oil in it? And what functional group is in fat or oil? That's an ester. And in your stomach, there's acid and water. So you have acid hydrolysis. That's reacting acid and water with something. And the functional group is an ester. And the general reaction that you learned for test number 3, ester, acid and water, you get back the carboxylic acid plus the alcohol you would have used to make this ester. Now that's how you describe with words acid hydrolysis of an ester and this general reaction when you eat a fat or oil. Now, how do you describe with words and a general reaction when you eat a carbohydrate? And what's the functional group that holds carbohydrates like starches, the glucose molecules together? That's an acetal. And that's the functional group. And I showed you how glucose molecules are held together. Well, in your stomach, there's acid and water. So you have acid hydrolysis of an acetal. And now, what's the general reaction? Well, you learned for test number 2 that if you have an acetal or ketal, then I'm not asking you to, when R prime is H, it's an acetal, but if you put down ketal, that's okay also. And you react it with acid, H plus is acid, and water. You get back the aldehyde or the ketone you would have used to make that acetal or ketal plus the alcohol. Now, it just so happens in carbohydrates, this alcohol and this ketone or aldehyde are connected together in glucose or fructose. Now, a reaction that you should remember from test number 2, if I take an aldehyde or ketone, react it with one molecule of an alcohol and acid catalyst, I will get a hemiacetal or a hemiketal. Keep your eye on the carbonyl carbon, which becomes this carbon because that's where the fun is. Now, when it's in the same molecule, and for this case, the alcohol is C5, you'll get a cyclic form. And know something? I'm going to share what would be the organic product or product there that when in this case, glucose reacts with itself to form this cyclic form. Have fun. See what a nice guy Dr. White is. And when you're done, give me a thumbs up or give me the high sign. I don't think you know what the high sign is. It's from our gang. While you're working on it, any of you happen to go online and see the live webcams for pandas? Years ago, my sister used to have sheepdogs and she kept them in full coat because she showed them in conformation competition, and they looked like either little bears or pandas. And I remember taking 2 of them for a walk, and back then sheepdogs are a lot bigger than they are now. And they weighed about 110 pounds each, and with their hair flipped out, it was pretty big. And I get people driving by and slow down like, what is that? And the most amazing thing happened one time. My sister went walking with my brother-in-law by their house, and there's this above train, commuter train called the Skokie Swift. And they're near the tracks, and this the arm came down, so they stopped because they were going to cross over to continue their walk. And the Skokie Swift came by, and it was 3 elevated cars, but at this point they're ground level. And she had her 2 sheepdogs, and one, Wendy, was the most beautiful sheepdog you've ever seen in full coat. And she was also a showboat too, and one of my favorites. And the train stopped. And the engineer and all the passengers were sticking their head out the windows looking at my sister's dogs, wondering what the heck is that? All right, let's get back to organic chemistry. All right. Remember, this R group and oxygen attacked the carbonyl. So that's this will tax that. And how do you draw that? Whatever is not involved in the reaction, I'm just going to rewrite because it's coming along for the ride. This oxygen here, which let me shorten this up so you can see it, is this oxygen here will be bonded to this carbon right here. So it's bonded. And notice on that carbon, you'll have a hydrogen. It's still going to be there. And the carbonyl here becomes a hydroxyl group. And you should know how to do that. Oops, forgot a hydrogen here. And that's how you do it. All right, let's do another one. Again, same reaction. Keep your eye on the carbonyl carbon. This attacks the carbonyl. The oxygen bonds to that carbon. It's always the C5 hydroxyl group. I'll let you have some more fun. What would be the product or product for the following reaction? And while you're doing that, I'm going to look out into the real world and see what's going on. Shouldn't have looked. Nothing good is going on out there. Well, the sun's shining. That's good. And when you're done, give me a thumbs up. All right, I see a lot of thumbs out there, so you must be done. Oh, I'll never use that joke again. That went over like a lead balloon or a screen door in a submarine. Bet you never heard those. We used to say that when we were kids all the time, which means you never heard that. All right, let's take a look at it. What do we have? We have this hydroxyl group like this one right here, attacks the carbonyl carbon. And here we have a ketone. And this is, by the way, I didn't write it down, but that's fructose. And whatever is not changed, I'll put the carbon here just to keep me. I rewrite this oxygen here is this oxygen here that will be bonded to the what was the carbonyl carbon. It's bonded to this carbon right here, which is this carbon right here, and then that will have a hydroxyl group. And that's how you do it. Don't forget to put this bond here. Same thing up here. Common mistake. Students just write it without that line, and it's wrong. That's right, like writing a six-membered ring like that. That's not a six-membered ring. You've got to have all the bonds. So those are important things you should know. And while Matt, a couple more, we hadn't talked much about it for a while, but remember, when it comes to polymers, you have two different classifications, one chemical, one by physical property. Chemical, you have addition, the same monomer type of monomer repeated over and over again, monomer. Condensation, two or more different monomers repeated over and over again. Example of an addition polymer, that would be saran wrap or your rubber tires of a car or bicycle too. And what would be an example of a condensation polymer? My plastic water bottle or other plastic things. What would the other type is by physical property, thermoplastic polymer, you should know, is a polymer that can be reheated and reused, in other words, recycled. And you have a thermoset addition, example of a thermoplastic, this. And the other type is thermoset. Once it's made, you can't reheat it and reshape it. An example of that would be your car tires. I think I gave everything you need to know. Now for my special surprise. Are you guys ready? Are you ready? I sound like SpongeBob. I haven't watched that in a long time. But anyways, have you ever thought about when they make something like fabric softener or something, or your detergent, and they make thousands or millions of pounds? How do they do that? Well, they do it in a chemical plant. And one of the things I did for many decades was work for chemical plants. One of my areas of expertise was problem solving in chemical plants, which is not always easy. And another one is helping bring new products from the lab into a chemical plant, which is called scale up. And that's part of my training once I got into industry as what's called a process development chemist, which I am, along being a synthetic organic chemist. And one way to think of scaling up, if you were to make breakfast for yourself or maybe another person, and you're making scrambled eggs, well, you take frying pan, you break a couple eggs, mix it up. I like putting a little water in that milk and put it in there with some butter, vegetable oil, season it and cook it. What if you had 10 people and you're serving up? Well, you got to have a couple of frying pans and more eggs. It's going to take more time for you to break the eggs, and that's scaling up. What if you had 10,000 people? You have to serve scrambled eggs all at the same time. Now you're in a different ball game. You need to consider, how do I get 10,000 or say 2 or 3 eggs per person, 20,000 eggs broken? Or do I buy it already out of the shell, which you can, I think. I'm not a cook, but, and what kind of equipment do I cook in? That's a whole new ball game. Well, it turns out chemical plants are the same thing. If you had been working in our lab, you'd see you work in small quantities, maybe to fit in a test tube, or maybe a couple ounces for those who are familiar with volumes, as opposed to English as opposed to milliliters. Well, in a chemical plant, you're working anywhere from 40,000 to, personally, I have up to 160,000 pounds per reaction. Now, to give you a feel for that, how many of you have ever seen the vehicle that delivers gasoline to a gas station? Those are called tank wagons. back in the day when they had horses, they put a tank on the back of a wagon to deliver liquids and stuff like that. I actually saw one in action for a celebration in Germany where the company I worked for was part German. It was a special Founders Day. I happened to be in Germany when they had that. Boy, it was fun. And chemists know how to party hard. But anyways, they actually had, the company had a old tank wagon. They hired someone with a team of horses to drive it around, and we all took pictures in front of it. I don't know where those pictures went. I have other pictures of that. But anyways, those are 40,000 pounds, 5,000 gallons. So when I'm talking about a reaction of 160,000, that's 4 of those in a container or some sort of thing. You're doing something. That's a lot of money. You don't want to mess up because you'll get fired if you blow, say, $500,000 in chemicals because you made a mistake. You don't. Also, if you make a mistake, you can kill people, which I'll talk about in a little while. I didn't, but at another companies. So what does this all mean? Well, like all chemical companies I work for, you're not allowed to bring a video camera or camera into a chemical plant because they don't want that getting out where their competition can see what kind of equipment they have. Well, it turned out one company I did work at, Borden Chemical, and this has never happened before or after in any company. I don't know how it happened, but it happened. About 2 or 3 weeks before it was going to happen, word got out throughout the whole company that the plant manager at the Louisville plant, which was their largest plant, was going to get fired. And that was wrong, first of all, but it got around. And I went down there a lot for problem solving and starting up new products to help out. And I knew the plant manager, Bill, nice guy. I don't know who got upset with him, but someone did. Anyways, I was going down there about 2 weeks before everybody knew he was going to be fired. He knew. And I said, hey, Bill, I'm coming down this week, spend a couple of days with you. Do you mind if I bring a camera? And he said, no, what do I care? What are they going to do, fire me? And he already knew. So he let me in. You don't usually allow to do that. And this is very rare. And I'm going to show you the inside of a chemical plant that most people don't get to see. Let's take a look. To use your imagination. With that, I think I'm done. Thank you very much. I'll see you on Monday. On Monday, I'll go through the test. Also, Monday next week and Wednesday, something that's helped all my students, and I get the feedback, it really helps them. I'm going to go through and do the reviews of all the chapters for the whole semester. I'll start with test 1 material, then I'll do 2, 3. I won't do 4 because on Monday I'll be going through test number 4. So I'll consider that the review. And one thing I will tell you about my final, the final will be set up. The first couple pages of the final will be from test 1, next test 2, 3, 4, and then some new material. I don't play shuffle of cards or 52 pickup. I haven't played that since I was a little kid. Want to play 52 pickup? Yes. And you do that with a deck of cards and throw them all over the floor. Did you ever do that when you were about 7 or 8 with one of your sisters or brothers? But anyways, I'll talk more about the final. And with that, I'm going to let you go. I'm going to send out the password in a little while. And with that, goodbye, gang gesund. Good luck on the final, on the test number 4, and I'll see you on Monday. Have a great rest of the week.